Hello everyone. We are working on the lab activity of optics topic. This is the chapter 4, refraction of light. So in this particular topic we are going to learn about refraction of light as it passes from rarer to denser material. But before doing that, I want to ask you a question. What time do you see sunrise? Let's say around 6:45 you see the sunrise. But do you really see sunrise? Do you really see the brightness, the white color glow and everything at 6:45, or do you see at 6:30 or 6:15? So what I am trying to point out over here is, even though the sun rises at 6:45, you can see the sunlight a little before the sunrise. That means half an hour before. Let's explore the reason why that happens. Now, imagine this is the earth and you are standing at this particular location on earth. That's you. Now, look at this line of sight. So that means this is the point where sunrise starts. So sun rises, so you can directly see. But what if the sun's position is much more below this line? So here I am putting the sun a little below, somewhere over here, and it's impossible for you to see the sun directly because it's not in your path of vision. So even though the sun is not in the path of your vision, you can still receive sunlight, because as light travels from sun towards earth, it bends a little when it enters into the earth's atmosphere. Instead of going straight in this path, instead of going in this path, the sunlight actually bends a little bit. This bending phenomenon happens because sunlight is traveling in between two materials. One is vacuum, another one is Earth's atmosphere. Whenever light travels from one material into another material, the light bends a little bit. It depends on the two materials to the bending phenomenon. This bending of light is responsible for seeing the sunlight even before seeing the sun. So that is called refraction. So in order to understand this topic, you need to know a few things. Let's call this interface. Interface is the surface that separates two different materials. Let's say at the bottom you have air and at the top you have water. So in this particular case, let's say light is traveling from air into water. Please tell me first, among air and water, which one is optically denser, which one is optically lighter? Water is optically denser. When we say optically denser, the molecules of water are closely packed and these can allow light to pass through. That's what is optical density. Since it is denser, I am putting the word D over here, or alphabet D, and here since it is lighter, I am calling it rarer medium. This is denser medium, this is rarer medium. So wherever the light touches the interface, I am drawing a normal to this interface. We never draw normals to the light rays, only to the interfaces. Let's say this angle is I. As light travels from rarer to denser medium, can you guess what happens? Will it travel straight in the same path or will it bend? If you understood the previous discussion, whenever light travels from one material into another material, it bends. Same way here also light bends. In fact, it bends towards the normal. Please see this. Instead of going in a straight path like this, it is bending towards the normal. This dotted line is called the normal. And we give normals always 0 degrees. So this angle between the normal and the refracted ray, this is called the incident ray. After bending, whatever ray you are seeing, we call it refracted ray. The angle between normal and the refracted ray is small r. And in this case, whenever light travels from rarer to denser, the beam or the light ray bends towards the normal. Towards the normal. Now, if you reverse this scenario, that means if light travels from denser to rarer, that means from water into air, then you will see the opposite phenomenon. Here it is rarer to denser towards the normal. There you will see denser to rarer away from the normal. So that is what happens over there. Now we are going to do an experiment to record everything. But before doing the experiment, I have a table. We need to fill up that table. And let's quickly recap. Refraction is a phenomenon where light bends whenever it touches an interface and passes into a different material. So here light is a straight line, here light is a straight line, but at this interface it changes its path. That bending phenomenon is called refraction. And second important concept that we learned is when light travels from lighter material to heavier material, we call it optically rarer and optically denser. Whenever light does that, instead of going in a straight path, it bends close to the normal. It bends towards the normal. So that is the concept. Now I am drawing a table, and after the table I will introduce the materials required for this experiment, and after that we can perform the experiment. So here I have already introduced what is incident angle, refracted angle. I am just going to use that. First one is incident angle, angle I. Second column is refracted angle, that means after bending, what is the angle on the other side of the interface. The third column is sine of incident angle. Fourth column is sine of refracted angle. And the last column is sine I by sine R. Okay. The angles we are going to choose, incident angles, we have control because we will be using a laser light to decide on these angles. So one is 0, next one is 10, 20, 30, 40 and 50. That's it. No more beyond this, because as you go beyond 50 till 90, the incident ray will diffuse, it will diversify, it will spread. When it spreads, it will be very hard to get the refracted angles. Okay. Now let's look into our apparatus, and after that I will explain the procedure of the experiment. So here we have all the apparatus that we require for the experiment. What I need is a laser light, and then we need a sheet. I call it full circle lamination sheet. If you observe this circle, you can see 90-90 line over here, 90-90, and this is 0-0 line. And another important material that we need for this experiment is a semicircle shaped glass slab. So what I am doing over here is I am placing the glass slab in this way. It's very important to keep it centered. You should not have half of it towards the other side. The middle of your glass slab should match exactly on the 90-90 line, and the center of the slab should match with this origin point. Whatever origin point you are seeing over here, that is where it has to be. And one side, as you can see, is air, that is the rarer medium. Other side is the denser medium. So our experiment now is to try 0 to 50 degrees and observe what is happening to the refracted angles. Now I am going to start with 0. That means light is traveling along the normal. Before I start, again observe this carefully. 90-90 is the interface. So the flat surface of your semicircular slab should be on the 90-90. And 0 is the normal. So the normal should be perpendicular to the flat surface. That's why we have it placed like this. Now let's get started. Now what I want to do is I'll turn it around. Observe the refracted angles. Okay. Or I'll put it a little back. Now we are starting with 0. So this is how you hold it. Don't put your fingers underneath the laser light. You need flexibility of operating it. Fix the laser light on the zeros line, make sure it is straight, keep pressing the button and slowly move the entire laser light downwards. When you move the laser light downwards, the light travels forward. And please see the result over here. On this side, you can see exactly on 0 degrees. If you are not able to see clearly, you can always bend the sheet a little bit like this. Not a lot, but a little bit. So please observe, for 0 degrees, I am getting refraction of 0. Okay. Now I am trying 10 degrees incident ray. This is 10 degrees incident and the angle I am getting is 6 degrees refraction. Observe on the other side. You are getting a little bit of reflection too, but that is not important. Our focus is to obtain refraction which is equal to 6 degrees. I will make a quick note here and later I will write on the board. So this particular, for 0 degrees, I have 0 degrees. For 10 degrees, I saw 6 degrees. Now I am doing 20 degrees. Please observe. That's 20 and I am getting somewhere around 13 degrees, 1, 3. It's very important to keep the laser light aligned in that direction. You should not cross it over. If you are using 30 degree, the laser light should be along the 30 degree. Now let's do 30. And make sure it always hits at the origin and the light has to go into the slab to get the perfect results. And now I'm getting around 20 degrees. For 30 degree incident, I'm getting 20 degrees refraction. Now 40, I'm getting 25. For 40 degree incident, I'm getting 25 degree refraction. And lastly, for 50 degrees incident, I'm getting 29 degrees refraction. One more time with the 50 degree. Yeah, around 29 degrees. That's it. It's a very simple experiment. Make sure everyone in the group tries at least 2 readings so that you can confirm if the readings are correct or not. Now I'm going back to the board where we have the table. I'm going to fill up these readings over there. Now if you remember, for 0 I got 0 degrees. For 10 I got 6 degrees. For 20 it's 13 degrees. For 30 it's 20 and for 40 it's 25 degrees and for 50 it is 29 degrees. Now what to do with these values and what is this sin I, what is this sin r, what is sin I by sin r. Let's look into these aspects. First we will complete the table, then we can look into what is sin I by sin r and everything. Now this is sin I column. The sin I column corresponds to I and sin r corresponds to r. So this is sine of refracted angle, this is sine of incident angle. Incident angle is 0. Sine of incident is also 0. We can keep it as 0. Now this is 10 degree. We need to find what is sine of 10. In the back of the sheet, I have already provided all the data. So if you observe carefully, there is a 10 degree over here. And beside the 10 degree, there is 0.1736. That's how you find all the values. For refraction of 6 degrees, the corresponding value is 0.1045. So this is how you find all the angles and we write it on the table. So without showing you further, I will quickly write all the values over there. Now for 0, it's 0. For sine 10 degrees, here you have to write the sine value. Here you have to find the r value, sine r value. Sine 10 degree is 0.1736 and sine 6 degrees, I have to write it here, that is 0.1045. Next, sine 20 degrees is 0.3420 and sine 13 degrees 0.2249. Few more, sine 30 degrees is 0.5, that is sine of 30 is half, as you are already familiar with everything. Now I am doing sine 20 degrees, that is 0.3420. Sine 40 degrees is 0.6428 and sine 25 degrees is 0.4226. 0.4226. Sine 50 degrees is 0.7660 and sine of 29 degrees is 0.4848.